Welcome. In this video, we'll take a look at using your Fcdf distribution on your graphing calculator to find the p-value associated with an F statistic resulting from an ANOVA test. So here's our example. Marketing managers are investigating 4 modes of advertisement for a product in 4 small communities with a different mode of advertisement in each community. The market managers have selected 32 days at random and are looking at the daily sales in dollars in each of the communities on each of these days. And they give us some of their sample statistics. And it says, suppose the marketing managers perform a one-way independent samples ANOVA test to decide if there are differences in mean daily sales arriving from these 4 different modes of advertising. So they're assuming that the only difference among these 4 communities is the mode of advertisement used in it. So they're considering one factor, and that's why it's called a one-way ANOVA. So the type of advertising. So let me go ahead and start by writing the hypotheses. So the null hypothesis in ANOVA would be that these population means, so the mean daily sales for the different modes of advertising are all the same, versus the alternative would be that they're not all equal. Another way to say that would be at least one mean differs from the others. So the alternative is just written in English here. So at least one mean differs from the others. All right, and let me get some of our variables here. So capital N is the grand total number of observations. So coming over to my sample sizes, sample size doesn't have to be the same for each of the populations under consideration, but in this case, they are each 32. So lowercase n would be the values for the individual modes of advertisement. The grand total number of observations would be taking all that data. So 32 days of data from each of those populations. Or of course, you could just do 32 times 4, but we now have a total of 128 pieces of data. So that's our grand total. K represents the number of populations under consideration, and that would be 4 because we have 4 modes of advertising. All right, so scrolling down a bit here. So the F statistic, which looks at the variation between the samples and the variation within the samples, rather than having to calculate that ourselves, they provide us with the information. So they give us their F statistic of 1.29, and we will find the p-value associated to it and draw a conclusion. So let's start with F statistic. So the F distribution has 2 degrees of freedom, one for its numerator and one for its denominator. So degrees of freedom for the numerator is k minus 1, and for the denominator is capital N there minus k. So in this case, we have 4 types of advertising, 4 populations under consideration. So 4 minus 1 is 3. And then our capital N was 128 pieces of data, minus k was 4 populations, and that's going to be 124. All right, so to find our p-value, ANOVA is a right tail test. So this will be the probability of an F statistic greater than the one that they got when they ran the ANOVA test. So this is what we would have called our test value or test statistic. So we're looking for the probability of F greater than that. And now we're ready for our Fcdf function. So we start with the value 1.29 and continue to the right indefinitely, so to infinity. And then the degrees of freedom of the numerator, and then the degrees of freedom of the denominator. All right, and then we head to our graphing calculator. So you're going to go to your distributions. So second, distributions, and you're going to look for your Fcdf function, enter, and then we'll just enter it exactly as it's written there, 1.29 E99, 3, comma, sorry, backing up, E99, comma, 3, comma, 124. All right, and that's our p-value, so 0.2809. So 0.2809. So the directions over there in terms of rounding say to round to at least 3 places. And we typically do 4 places for our p-values. And I'm just going to write that in a percent version as well. That's a very big p-value, 28.09%. So let's write our answer here. So put that in decimal. And then they ask us to draw our conclusions at a 0.10 level of significance. So let me just write my alpha here, and I like to do that as a percent. So the alpha was 10%. So now I can see that my p-value, 28.09%, is definitely bigger than my alpha value of 10%. All right, so our p-value is not low. So we do not reject the null. And that means that we are not going to be able to support a claim that the type of advertising creates a population mean in at least one of these types that would be different from the others. So it says, using a 0.10 level of significance, can the marketing managers conclude that the mean daily sales arising from at least one of these modes of advertisement differs from the others? So no, I cannot draw that conclusion because I do not reject the null. Therefore, I do not support that claim that we were testing. All right, and there you have it. So the summary here on this type of problem that you see on ALEKS is that if you are given the F statistic, then you don't have to run the ANOVA test. You just have to find the p-value associated with that F statistic using your Fcdf function.